Alrighty, everybody. I just got the okay to start the show, so I want to put away our space trivia questions up on the screen because now we're going to be heading into the unknown. Ooh. And once again, everybody, welcome to the Morrison Planetarium. Just a heads up, I want to introduce myself real quick. My name is Christian. I want to be your planetarium presenter for this afternoon. And just to let you know, I'm actually a person and I'm standing right behind you up in the planetarium control. Hey, how's it going, everybody? But don't hurt your necks. Look forward into the dome before you. Everything that you see in purple is going to be one enormous screen. Thanks to the help of 6 different projectors hiding throughout this planetarium dome. We've got 2 at the bottom, 2 in the middle, and 2 at the very top if you're looking for them. And just a heads up, folks, the show that we're about to do right now is different from all the other previous shows that we've done in the Morrison Planetarium today. This one is called Tour of the Universe, and it's personally one of my favorites to do. Essentially, what we're going to be doing here is that we're going to start off pretty close to planet Earth, and then we're going to be zooming all the way out to the very edge of the known universe. And hopefully, by the end of this show, you won't have an existential crisis of where we are in the universe because we humans, we're very tiny. We occupy a very tiny space. And before we get started, I got to go over some quick house rules just so that we're all on the same page. We can have a great experience inside the planetarium. First off, there's no food or drinks allowed inside. So if you manage to bring any snacks or beverages, make sure those are tucked away to the very end of the show. We want to make sure this theater stays nice and clean for all the folks coming in today and in the future. So thank you so much, folks. This also includes no feetsies on the seats because, again, we want to make sure the seats are clean for everybody coming in. Also, folks, if you happen to have any cell phones or smartwatches or anything that produces bright white light, now is the perfect time to turn them off, deactivate them, put them away for the next 30 minutes or so, just because these devices produce really bright white light that can be distracting for the folks sitting behind you. So we want to be courteous to all of our guests here in the Planetarium Dome today. Also the biggest one of them all, please wear your mask while you're inside the Planetarium Dome. We want to make sure that you're wearing them even during the whole presentation, even during the dark parts. And by wearing a mask, it does go over the nose. So thank you so much, folks. Can't stress that enough. And also, folks, if you need to leave the planetarium for any reason today, please make your way up the stairs. That's where the exits are going to be before, during, and after the show. So when in doubt, always make your way up the stairs, not down them. And lastly, folks, this show can become very immersive. If at any moment during the show becomes too overwhelming or you become motion sensitive, there's a really quick and easy solution for you to ground yourself. All you got to do is close your eyes, take a few big deep breaths. Your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling through space, at least not more than the usual. But otherwise, that's all I have to say. Y'all ready for a fun planetarium show? Alrighty, everybody, let's get started. Alrighty, like I mentioned, we're starting off pretty close to planet Earth today. Not too far off, we can see the Earth just below us, that nice little blue marble down below. But we're starting off something kind of unusual looking, at least for us humans. What we're looking at today, right now, folks, is what we call the International Space Station, or what we like to call the ISS for short. Now, the International Space Station is an amazing feat of humanity, at least in my perspective. Essentially, what this thing is, it's a research facility that's orbiting around planet Earth, and this is between a collaboration between many nations on Earth to pretty much figure out what happens to things in space. For example, how do plants behave out in a low gravitational environment? How does water or fire or electricity work out here in a low gravitational environment? So they conduct all sorts of experiments up here at the International Space Station. So a lot of cool science experiments. And when we're looking at the International Space Station, folks, it looks really far away from the Earth. We can see, I believe, is the east coast of Australia just down below us. And it looks really far away, way up high. But the International Space Station isn't too far away from planet Earth. It's only about 225 miles above the surface. Well, 225 miles, that's like a nice little family vacation from San Francisco to Santa Barbara, a nice little family trip to get away for the weekend. And folks, what's really amazing about the International Space Station is that it's going incredibly fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunsets and 16 sunrises a day. Whew, how romantic. But folks, let's see. Oh yeah, this thing's also quite large as well. Well, not too big. Right now it looks enormous on our screen, but it's only about the size of a football field. But it keeps getting bigger every year because they keep adding new compartments to the ISS. So that should be growing in the years to come. But the International Space Station fits about 6 to 8 astronauts comfortably at a given time. And folks, this is as far as we put humans into space nowadays because traveling into space gets quite costly quite rapidly. First off, you need to find yourself a rocket ship or build yourself a rocket ship that works properly. Then you need to get yourself rocket fuel for that rocket ship. Then you need rocket fuel to get that rocket fuel off the planet, and more rocket fuel, and more rocket fuel, and more rocket fuel. And let's say more rocket fuel like 3 or 4 more times. And then you got to bring all the technology equipment with you for life support. And then not only that, you're going to need to bring all the food, water, and air you're going to be breathing while you're in space. So the bill starts to get quite costly quite rapidly. But for now, folks, we're going to leave the International Space Station behind because now we're going to slowly see it disappear compared to our planet Earth. While we zoom away, we'll still be able to keep track of it thanks to our nice little orange marker that'll keep or show us the trail of the ISS. And just to let everybody know, right now I'm using a really fun space software called OpenSpace. So this is a different software that we used in previous shows. OpenSpace is quite amazing in my opinion. You're more than welcome to download it at home at openspaceproject.com. But just a heads up, if you're going to download this, make sure you have a very powerful computer that can process a lot of information because this is quite heavy on using your RAM on your computer. So if you have a gaming computer or a really good desktop, highly recommend using OpenSpace. Super fun to fly through the universe. But we're going to leave planet Earth for just a moment, folks, because now we're going to be heading over to our nearest natural neighbor to us in space, the moon. Now, we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon, play golf, and of course, conduct science experiments up here. But again, that was the only brief presence of humans on another body in the solar system, and that was a little more than 50 years ago or so. And it looks like right now we've got a lot of darkness on the near side of the moon, so I want to turn off the nighttime so we can get a nice look at it and see what we're familiar with. Hey, moon, good to see you. But folks, no worries. We humans are planning to send humans back to the moon again. Well, NASA is at least with NASA's new space mission, which is going to be called Artemis, which is pretty funny because Artemis is the sister of Apollo in Greek mythology. So Apollo, Artemis, it works really well. They're really funny. But what's amazing about Artemis is that they're going to be sending the first woman to the moon. But not only that, they're also going to be setting up the first lunar base here on the moon. Essentially, NASA's main goal is to send humans to Mars. But before we send humans a really long trek away that can take at least 6 to 8 months to get to Mars, and then wait a whole year for it to go around the sun, and then we wait for the closest between Earth and Mars. That's another 6 to 8 month journey, so about a 2 year voyage altogether. That's really far. We want to start off something closer to home, something that we can figure out how we humans can figure out living on another celestial body. So the moon is the perfect stepping stone for us to figure out those processes. But Artemis should be launching in the next year or two, so keep your ears out for any news about Artemis. I'm really excited for this NASA space program. And folks, when we look up at the moon here on the nighttime, or at least here on Earth, it almost feels like you can reach out your arms and touch it, especially when the moon's close to the horizon. But the moon's actually quite far away from us. It's about 240,000 miles away from the Earth. That's about 250,000 miles. Woo! Now, some of you folks may own a car with that many miles on it, and if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop. Although I cannot recommend it, the roads are poorly maintained out here. Hee hee hee. But from here on now, folks, we're going to need to use a more useful measuring stick. Since at this scale, using miles is kind of like using inches to describe the distances between cities. Astronomers instead used a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it takes light only 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But for now, folks, we still have a ways to go to get to the edge of the known universe. So we're going to say bye bye, moon. So everyone say bye bye, moon. We'll see you later. And now, folks, we're going to be taking a leap into a much greater realm of our solar system because now we're going to watch the moon and the Earth and their orbits as they slowly recede. And on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, showing us the most accurate images and information available to us. I'm going to be bringing up the planet trail so we can figure out where everything is in our solar system because out here, it's really hard to find these objects. So we can see the moon and the Earth closest to us. But now we can also see the nearest star to us, the sun, comes into view. And the sun's about 93 million miles away from the Earth. Whew, 93 million miles away. That is a long distance. But in terms of speed of light, that only takes light 8.5 minutes to cross that distance. So not too long. But again, folks, from the sun to the Earth, 8.5 minutes to travel that distance. Now, this is a really cool concept to keep in mind. Out here in space, when you're traveling really far distances, it takes a while for that light to reach the eyes or the observer. So, say if the sun was to turn off all of a sudden, we wouldn't know about it for 8.5 minutes because it takes that light that long to travel that distance. And then all of a sudden, here on Earth, it would be nighttime all of a sudden if that sun was to turn off. So again, great concept to keep in mind. This also works for really far objects like, say, a star. Let's say we see a star that's 10 light years away. Well, we're seeing that star as it looked like 10 years ago in the past because it took that long for that light being emitted to travel that distance to reach us. So it took 10 years. So we're looking at that object as it looked like 10 years ago in the past. So when we're looking out into space, it's kind of like traveling back in time in a sense. Pretty cool. And before we leave our solar system, I do want to name the planets in our solar system. But first off, in the middle, we have Sol, our sun. And then closest to the sun, we've got Mercury, Venus, Earth. That's us. And then we have Mars. These are the rocky terrestrial planets. These are places we can actually send spacecrafts to, although some of them we wouldn't want to because the weather there is quite extreme. And then beyond Mars, it kind of looks empty, but it's not quite that empty. Beyond Mars, we have our main asteroid belt. And this is what it would look like if we were to highlight all those asteroids in our asteroid belt. Now, a lot of people tend to think because of Hollywood that the asteroid belt is filled with asteroids. You have to dodge and weave to get your spacecraft through, but it's actually not the case. There's so much space between out here in the main belt that you can actually fly your spacecraft through the asteroid belt with no problem. There's about a 1 in billion chance of your spacecraft getting hit by an asteroid, so it's not like in the movies where you have to bob and weave to avoid those asteroids. But we're going to be leaving, or we're going to continue on. And now we're going to be seeing the large Jovian planets, the gas giants. We've got Jupiter and Saturn. And then beyond them, we have the icy giants. We got Uranus, the funny one, and Neptune. But I can already hear a few folks asking, hey, what about Pluto? I learned about Pluto in school. Pluto is still a planet. How come you're not bringing up Pluto? All right, folks. Let me bring up Pluto for you. And here is Pluto's trail. You're going to notice that Pluto has a slightly different trail than all the other objects that I just mentioned. Pluto has a more eccentric tilted orbit. And again, folks, Pluto is no longer considered a planet. It's now considered a dwarf planet. You're probably wondering, why did Pluto get kicked out of the Planet Club? Well, you see, folks, we humans got really good about learning about our solar system, specifically the outer part of our solar system beyond the orbit of Neptune. So that's really cool about science. The more that we learn about the universe or things around us, we can start to adapt and change and make adjustments to the things that we find. So in 2006, we got really good about learning our solar system, and we found a lot of things beyond the orbit of Neptune in the Kuiper Belt region. You're probably wondering to yourself, what's the Kuiper Belt? I've never heard of that. Well, the Kuiper Belt's going to be all these things. Woo, there it is. So this is the Kuiper Belt, folks. This is essentially a second asteroid belt that exists beyond the orbit of Neptune. And out here, it's mostly icy asteroids and icy comets, but we found more than 400 objects out here, and some of them were way bigger than Pluto, so we couldn't call all this stuff planets. There was just way too many of them. So all the astronomers across planet Earth came together, had a great big meeting. They had to figure out what exactly you need to be to consider a planet, and one of the criteria to be a planet, you need to be so big and so massive that you push all the other things out of your orbital path. Unfortunately for Pluto, it's not the biggest thing in its orbital path, and it also dances with its own moon. So this is one of the reasons why Pluto got kicked out of the Planet Club and now considered a dwarf planet. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding the spacecrafts that we sent out in the 1970s to explore our solar system. There we go. So again, these are the spacecrafts that we sent out in the 1970s to explore our solar system. Right now we have Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. And last of them, the latest of them, we have New Horizons. All these things are traveling fast enough to escape our sun's gravity and leave our solar system behind. But what's really cool is that New Horizons did a quick flyby with Pluto in 2015. We can actually see where Pluto's orbit is right here, where it intersects. And you can see that it made a quick flyby in 2015. Thanks to New Horizons, we got some amazing high definition images of Pluto. In the past, our photos of Pluto were pretty much just pixelated dots, and we couldn't get a whole lot out of that. But thanks to these new high definition images, we learned so much about this dwarf planet. I can do a whole show about Pluto. It's so fascinating. But that's something for another time. But we're going to be leaving our solar system now, folks, because now we're going to be heading in interstellar space, the space between the stars. Now, distance becomes so immense that it's going to take us over 4 years at the speed of light to reach the next star system to us, which is the Alpha Centauri system. And if my calculations are correct, this is Alpha Centauri right over here on the left-hand side, the closest star. So 4 years at the speed of light to travel to the next star system. 4 years, well, that's about the same amount of time for a college education from freshman year to graduation, at least before the budget cuts. He. But folks, we're going to stop and consider whether humanity has made its presence known beyond our stars nearby us, because now we're going to be heading inside the radiosphere. So we are now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this began in the early 1930s with strong radio waves, early television, and radar signal, and then later the detonation of atomic weapons. All these things are emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, folks, the radiosphere is always expanding at the rate of 1 light year per year, so is anybody out there listening? But folks, also I'll be bringing up these markers. These markers represent some of the many thousands of stars astronomers have discovered over the last 22 years, which has one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far to date, we found more than 4,000 exoplanets just in our nearby vicinity to us. In fact, if we turn our screen over, we can see a huge chunk of survey right over here on the right-hand side. So we just pointed our space-based telescopes and we found a whole heap of exoplanets. So that 4,000 number is going to be increasing in the near future. As we continue scanning more of the night sky, we'll be finding exoplanets left and right. So I'm very excited to see what we find. But in terms of figuring out if any of these exoplanets are Earth-like with conditions suitable for life, that's a different story. Our technology is not yet able to answer that question, but new generation of astronomical instruments are devoted for that search. But the important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we're on the far left side of our radiosphere. Let's say this planetary system. We find an alien civilization on the far right. Let's say this one right here. We shoot them a text message. Hi, takes 90 years to get to them. They listen in, answer back. Another 90 years back. That is a 180-year conversation in the making. Whew, and I could barely wait for a text message from my friend. But, folks, of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. But for now, I'm going to put away these exoplanet markers, and I want to leave our radiosphere up there, just because the radiosphere is a great reference point. As huge as our influence is of humanity, it is nothing compared to the Milky Way Galaxy. So keep your eyes on that radiosphere. Let's see if you can still see it as we zoom out. All right, folks. So now we're looking down on our Milky Way Galaxy. And you can still see our radiosphere right there in the middle of our screen. But looking down on our Milky Way Galaxy, you notice that this thing is quite enormous. If you want to cross one side of the Milky Way Galaxy from one side to the other, it's going to take you 130,000 years at the speed of light. Now, that is a very long road trip. But not only that, our Milky Way Galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth like planets throughout our single galaxy. And before we leave the Milky Way Galaxy, I do want to stress the shape of it. When we look at the Milky Way from a sideways perspective, you notice that it looks like a flat spiral pancake. Now, this is pretty important to keep in mind because when astronomers and scientists want to learn about the universe, it's so much easier for them to point their telescopes and equipment galactically north and galactically south instead of looking straight through the plane of the Milky Way, which has stars, planets, gas, debris, nebula, which obscures their view of the universe beyond. So just keep that in mind. We live in a flat spiral disk of the Milky Way Galaxy. I'll come up in just a little bit. But folks, the Milky Way Galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. Now in this giant leap, we're now going to see a view where each point of light represents not a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local group which contains about 30 galaxies, large and small. It also includes the nearest large spiral to us, the Andromeda Galaxy, which is only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. Hee hee hee. And folks, as our picture starts to expand, you're going to start to notice that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large clusters or great regions or voids that have very few galaxies. In fact, we can see a nice galaxy cluster right over here. I do believe that's the Virgo cluster. And then we can also see regions where there's very few galaxies that we can observe. So just keep that in mind. Galaxies like to hang out together or they like to stay away from each other. But now, folks, we zoom so far back out now that we are looking at a picture that represents the 30,000 closest galaxies to us in space over 300 million light years across. We've got to give a special shout out to a really amazing fellow by the names of Dr. Brent Tully, who worked at the University of Hawaii, who compiled this representation, this galactic map that we're able to fly through our planetarium dome today. He also did this with the work of dozens of other astronomers working over decades of time, and they even color coded the densest regions of galaxy clusters in orange that we see here on the dome before us. But now, folks, we have automated systems that are mapping the most distant galaxies, so now we're about to view the large-scale structure of the universe. And remember, every single point of light that we're seeing is not a star, it's an individual galaxy. Woo! There's a whole lot of stuff out here. And by the way, folks, the large-scale structure of the universe is not shaped like a bow tie. Remember when I just mentioned that we live in a flat spiral disk of our Milky Way Galaxy? Well, if we were to line up our Milky Way Galaxy, it would line up right in the middle where these dark regions are. So again, astronomers and scientists point their telescopes galactically north and galactically south instead of looking through all that gas and debris of the Milky Way Galaxy. But folks, we should be able to. We humans still wanted to make sure that there were still galaxies through the plane of our Milky Way. So we have a nice little purple survey of galaxies, a little bit much more closer to us. We didn't get as many galaxies far out because of the Milky Way obscuring our view of the universe. But it's only a matter of time before we fill in all these dark regions. As our technology progresses, we'll be able to look through the plane of the Milky Way and then map out more galaxies. So you can imagine all this stuff that we're seeing, but in every direction if we look. And one of my favorite things is to fly through all these galaxies just because it looks really fun. But it looks like we're running close out of time, so we must continue on to the very edge of the known universe. And as we continue going, we're now going to start to see the quasars, which are short for quasi-stellar radio sources. So the quasars are going to be located at the very outer edge of the large-scale structure. These are going to be the orange dots on the outskirts over here. So these are the quasars. Now, quasars, these are blazing objects. They're all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So now we're going to continue to a time before quasars, to a time before planets and stars and even galaxies began to form. Folks, we are now approaching the very edge of the known universe. And here it is. So, folks, we are now looking at the cosmic microwave background image, or the CMB image for short. Now, all evidence indicates that the universe that we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. But the picture we're looking at is a very baby universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo, but a temperature density image, where the light echoes of the Big Bang are color coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But eventually, they gave rise to that large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how this happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us, so we only have one direction left to go, back home. Now, before we make our return trip back to planet Earth, I've got to ask everybody to prepare yourself, because this could possibly be the worst free falling dream ever. Hee hee hee. But let's find a nice entry point through all these quasars and galaxies. There we go. And let's make our return trip back home, folks. So we're crossing an expanse of 13 billion light years. We present you with this view of the universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecraft that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, everybody, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to take a look through their telescopes and peer to the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just entered our Milky Way galaxy. We're heading straight for that radiosphere. And of course, we are making our way downtown, walking fast, and our faces pass, and we're homebound. But now we're approaching our planetary system, our star system. Passing those spacecrafts that we sent out in the 1970s to explore our solar system and the orbit of Pluto and the Kuiper belts. And folks, as we make our final approach back to planet Earth, the third rock from the sun, this is going to be the end of our Tour of the Universe show. And I want to thank you all for stopping by and watching it with me today. I hope you did enjoy it. But again, this is the only place humans have ever called home, which is planet Earth. So remember to take care of it, folks. We've only got one planet. And as we make that final approach, that's going to be it for today, folks. Thank you so much for stopping by. And we made it back home safe and sound. We'll see you next time.